This is an edited version of a webinar I did for the SEN group in 2018. It explains the teaching of mathematics, the basics, the foundations, the method used in Maths Explained, the tutorials. So I'm going to start with the key thing, that's just writing the numbers as symbols. Maths is so much about symbols, which incorporates place value. Absolutely crucial for the understanding of maths. So in this introduction I'm going to look at 1-digit, 2-digit and 3-digit numbers. I'm going to use visual images. If you were using this in a classroom, these methods, you might want to also use manipulative materials. So there are two key moments in early numbers. So children often learn to count to 10. So 9 to 10 is a key moment. We'll see why in just a moment. And that is because 9, 1 digit, becomes 10, which is represented by 2 digits. Always in maths we have to learn how to reverse procedures. Key skill in maths. So we have to be able to go from 10 to 9. So from 2 digits back down to 1 digit. So important. So here's a pattern for 9. Now I choose to use this pattern because it focuses on the key numbers. And you'll see that more clearly when I add the 1 to make the 9 into 10. So here we're seeing 10 as 2 5s. 10 is to do with the fingers on our 2 hands, 5 on each hand. So 2 5s are 10, a key moment in maths. And of course the reverse, to go from 2 digits back down to the 9, the 1-digit number. Symbols and visual images are very important in the way that maths is taught in Maths Explained. So I'm going to take the 10 ones in the pattern to start, the 2 5s pattern. So you can see, you can recognize that pattern as 10. Now what I want to do is to take those 10 ones and make them into a rod. And so my next image is going to be to swap the 10 ones for this 110, this continuous rod. So in these videos and in this video and the Maths Explained videos, that's the symbol we're going to use for 10. So symbol for 1, a symbol for 10. And you need to be familiar. Recognizing these images, these objects, has to be automatic and linked always to the digits and the numbers. So apparatus and image, excuse me, linked to the images. The blocks, by the way, are usually called either base 10 blocks or Dean's blocks. So place value, key to maths. The value that a digit takes depends on the place it holds in a number. So let's start with 11 and 12. Well, 11 is the 2-digit number after 10. So it is 110 and 1 1. So we write this as 1 followed by 1. That 1 is 1 1. That 1 is 110. And it becomes 110 because of the place it holds in the number 1 1, 11. And unfortunately 11 and 12 are exceptions. In some languages, Welsh, Cantonese, 11 is said as 110 1 and 12 as 110 2. So let's look at 12. There's 110 1 for 11. Here's 12. 110 2 1. So now we've got 2 different digits. The 1 in the 12 is 10, the 2 is 2 1s. Now, one of the things I do in Maths Explained is to scaffold the learning. So that's very important. So here's some scaffolding coming up. So when we start with showing numbers and place value, that's my scaffolding. So 13, the 1 goes in the tens column, the 3 goes in the ones column. And same for 14 and 15 and 16 and so on, 17, 18, 19. Now it's unfortunate that the first two-digit numbers we meet in the English language, 11 and 12, which are exceptions, and then the teen numbers, the vocabulary, the words are actually back to front compared to the symbols. So we say 13, and the teen represents maybe the 10 and the 3, but we write 1, 3. So in a sense, the word is in reverse to the symbols, and of course, vice versa. And so the scaffolding is very important when we meet this first set of two-digit numbers, so we really know what we're doing. Of course, what we do is to take away the scaffolding, the images, the columns, the words, so we're left with just 13, 1, 3, 16, 1, 6. Fortunately, after the teen numbers, things get better, so we get 21, 2 10s, 1, 1. 22, 2 10s, 2 1s, and so on. And 30, of course, and so on. And then we slowly head, or quickly head, depending on how quick you're counting, to 100, 96, 97, 98, 99. 99 is the largest two-digit number, and you can see it's made up of 9 10s and 9 1s. Place value again. The next number is 100, and that's three-digit, 1, 0, 0. So that's represented either by 10 10s, which again I've split as 5 and 5, so you can see 50 plus 50, or this block, this 100 block, which is the image I use for 100. So the scaffolding I would use to represent a three-digit number would be this. There's the scaffolding representing 139 as 100, 3 10s and 9 1s, with all that scaffolding there to support the understanding of each digit. Another key part of Maths Explained is to use what you know to work out what you don't know. A lot of times maths is taught just by remember this, remember this, remember this. I want to link things because maths is great for that. Well, this is a piece of very key research from a very large study in the USA. And it says, if you're going to be good at any area of inquiry, you must have a deep foundation of factual knowledge, understand the facts and the ideas in the context of a conceptual framework, and organise your knowledge in ways that help you retrieve it and apply it. Well, I'm going to use patterns and generalisations. Lots of research in maths to say how important that is. And I want to talk about that deep foundation because in actual fact, if you're good at B and C, you can go such a long, long way if you really have a deep foundational knowledge of these key facts, the ones based around 0, 1, 2, 5, 10, 20, 50, 100, and so on. And that is very important in maths. So this organising your knowledge is a very big part of the Maths Explained. Understanding multiplication. So let me give you an example about understanding. Well, it's usually defined as repeated addition of the same number. So we're linking multiplication and addition and interlinking the four basic operations, add, subtract, multiply and divide. Again, key to understanding maths. And we'll be using those key facts. So if multiplication is repeated addition of the same number, then 4 times 5, 4 lots of 5, 4 multiplied by 5, 4 5s, vocabulary going nuts. Then 5 plus 5 plus 5 plus 5, we write as 4 times 5. So 7 times 8, pretty difficult fact for a lot of people to remember, is 7 lots of 8 added together. And that's what we're seeing here. Again, this repeated addition, which is so important in mathematics. And I talked again about vocabulary and symbols and all the different words we use for multiply. Bit of a pain. Using what you know to work out what you don't know, you can use this method to work out all these facts as well, using again the core facts. I'm just going to give you a couple of examples, 6 times, 7 times, to show you how this works out. So 6, you've got to recognise the core numbers in 6. Well, they're 5 plus 1. Those are the core numbers, 5 plus 1. And 7, you might work out for yourself, is 5 plus 2. So those are the core numbers. And let's use a two-step strategy. If you find something too hard to do in one step, it's good to use 2 steps, and we're going to show you that now. So this method is chunking 6 down into 5 and 1, 7 into 5 and 2. These are called partial products, and we'll use them later in much more complicated multiplications. And part of Maths Explained is to use easier work to build your foundations for harder work. So there's my 6 sixes as repeated addition of the same number. Here's my chunking, 5 lots of 6, 1 lot of 6. So you need to know 5 sixes are 30, 1 6 is 6. We get 36. And if you want to do 6 eighths, it's 5 lots of 8 plus 1 more 8, 48. Let's show you 7 times, because the principle's the same. Multiplication, repeated addition, same number. 5 lots of 6, 2 lots of 6. So you have to know 5 sixes are 30, 2 sixes are 12, so the answer is 42. 7 eighths, you have to know 5 eighths, 40, 2 eighths, 16, 40 plus 16, 56. So we're getting pretty good at this using stuff. Right, fractions. A quick introduction to the concept of fractions and symbols you see and symbols you don't see, which happens in maths. So here's one circle. And I'm going to divide it into 4 equal parts. So 4 equal parts. And I'm showing you 4 out of 4 equal parts. That's how we write it. That's now showing you 3 out of 4 parts. And I'm now showing you 1 out of 4 equal parts. One of the great ways you can understand fractions is to use paper and fold or cut it. So let's just look at 1. Divided into 2 equal parts. One of those parts, 1 out of 2, is a half. So that will be a third, 1 out of 3 equal parts, and that will be a quarter or a fourth, 1 out of 4 equal parts. And you can see that 1 over 2 is bigger than 1 over 3 is bigger than 1 over 4. So all of a sudden 2, 3, 4 is getting smaller because we're talking about fractions. Well, fractions hide the divide sign, as I've just shown you there, and you mustn't forget that hidden divide sign. We're challenging previous learning. You have to inhibit what you've learnt before. And a very simple illustration of this is, let's do a half, let's do a third, 1 divided into 3, so the parts are smaller, and a quarter. So showing you physically again that the parts are getting smaller. Well, just to finish, here's something a little bit more complicated, but not much. Take a strip of paper, fold it, that will show you a half. Fold it again, that will show you a third. And again, that will show you a quarter. And again, that will show you 1/5. And one more time, a tenth, that will show you a tenth. Now, if I can put those onto a number line as decimals, then I've cracked fractions. So here we go, here they are, going onto the number line. Half. See how they go on the number line? A third, a quarter, a fifth, and a tenth. If you can do that, you understand fractions.